So with 2/3 times 6 with multiplication, the very beginning of multiplication is that it's repeated addition. I'm going to take whatever it is and add it over and over and over. Like I said, like 2 times 3 is 2 plus 2 plus 2. Or 3 plus 3. Because either way, you still get 6. So I can take 2/3 and add it how many times? 2/3 and add it how many times? How many? Do I have only one person in this room today? Did y'all come to school today? Well, you should have brought it. So, because I'm asking questions, you need to be able to answer them. So, if I have 2/3, how many times am I going to add it? Y'all got to perk up because they are leaving y'all in the dust of answering questions. So, there's 1. There's 2. There's 3. There's 4. There's 5. And there's 6. It's not the quickest way to do it, but it is a way to do it. That was great. Do I add my denominators?
No.
No, I'm still going to have it over a denominator of 3 because I do not add my denominators. I never add my denominators. So when I add my numerators, I just count by 2 because when I'm adding 2, 2 plus 2 plus 2 plus 2, I just count by 2. I cannot hold on to this marker with it. 2, 4, 6, 8, 10, 12. It is improper. So when I have an improper fraction, I divide. I divide up. 12 divided by 3. 4. So my answer is 4. 2/3 of 6 is 4. That's one way you can solve this problem. That's one way that I can do it. Or I can switch it around. Because isn't 2 times 3 the same as 3 times 2?
Yes.
I can reverse it. The only thing I can't reverse is subtraction and division. Addition and multiplication, I can flip it around either way. So, I can do 6 copies of 2/3. 6 times 2/3. So, I can also, what we learned yesterday, do a bar model. What goes on the top? 6, my whole number. This probably goes with this. 2/3 of 6 would be this. I guess it's backwards. So how many pieces am I going to have? 3. What? I heard a, oh, were you yawning or was that like someone going, so 2/3 this, I did things in the wrong order. So 2 parts of 3. So I got to do right here. 2/3. This is what we did yesterday. Okay? So I've got to figure out what 1 unit is worth. 6 divided by the 3 units. So I've got to figure out what 1 unit is. So this unit is 2. So this unit is 2. So this unit is 2. So if I have 2 of them, it's 4. So this is one way I can do it. This is one way I can do it. So that's 2 different ways that you can do this problem. What? Or I can do standard algorithm, which I'm going to show you right now. Well, there's 2 different ways you can do standard algorithm. One of them, some of y'all are going to go, yes. And a couple of you are going to go, I don't get it. And if you don't get it, don't do it. Okay? So I'm going to erase all this. I'm going to run out of room. All right? So the bar model is fine. If you get bar model, great. But sometimes y'all yesterday with the bar model, some people were not doing it right. Bar model's fine. If you like it, great. But you need to build up to standard algorithm. These are just like the beginning part. You need to work up to standard algorithm because this is really going to take a long time. Okay? So let me clear this off. Was anybody writing this down and needed me to wait? You need me to wait? You got to say it. Strictly need you to wait. All right. So I'm going to write this twice. Okay. So the first thing I'm going to do is I'm going to do what I call smoosh math. And this is, I just made this up myself just because it makes it easier for people to remember what I'm doing. Okay? So when I do what I call smoosh math, it just means that I take the top and the bottom and I kind of smoosh them together. I make it one problem in the same spot. So I do my 2 times 6, I put them together. My numerators are together. My denominators are together. What am I multiplying by 3? 1. What's underneath that 6? 1. A 1, not a 6, because 6 over 6 is 1. Is this one whole? No. It's 6 over 1. Every whole number is over a 1. So that should be 3 times 1. So I'm just kind of smooshing them together. So then I have 2 times 6 is 12. 3 times 1 is 3. It's the same thing as me going just multiply straight across. This is kind of maybe keep me from doing the thing that I told y'all not to do. Okay? There are some people that are going to be determined not to listen to me and do that butterfly method that I say don't do. The butterfly method that some of your teachers may have taught you how to do, I did do it when I was younger. That's when you're dividing fractions. And I still will not teach you how to do that. I'm not going to do it. Because if you're not careful, you will do it wrong. That's why I don't do it. You have to do it a certain way. So I'm not going to teach it to you. 12 divided by 3 is 4. So this is how we've been doing it with your standard algorithm. Some of you need to just stay here because you might possibly not understand what I'm about to do. And I'm not throwing shade. This is just the way it is. It's not super hard, but some people just really cannot take it to 2.0. And that's okay. So the first thing I'm going to do is my smoosh math. That step is the same. This just takes a little bit extra paying attention. Okay? This is all I have to do. It's almost like simplifying within the problem. If you are able to simplify fractions like we did in second quarter, then you're going to be able to do this. Is there a number not including 1? 1 does nothing but make everything stay the same. Is there a number in the bottom that can go in the top, like divide? You are simplifying within the problem. 3. 3 can go into 3. It has to be able to divide within the problem. So 3 can go into 3 and 6. So what you're going to do is 3 can go into 3 how many times? Once. So 3 now becomes a 1. 3 can go into 6 how many times? 2. So I divided only those 2 numbers. We're going to do this more than once. See, it's like some of y'all are like, oh, dude. And it makes it to where a lot of times you don't end up with an improper fraction. 2 times 2, 4. Oh, Eureka! Sometimes you cannot do that step. Sometimes there's no number that goes into anything, and you can't do that step. I know, I love this step. Sometimes you don't recognize it, you don't see it. You okay? You need water? Okay. So when we are doing this work in class, I'll be doing both steps. I'll do both. Okay? So we'll be working on it. We'll be practicing it. So sometimes you'll see it, and you'll be like, oh, this is super easy. Sometimes you won't see it, and you'll go, dang, I didn't see that. So that's when you really need to be paying attention to your divisibility rules, your basic facts. You know, is there a number that can go in the bottom and somewhere in the top? And it's normally like this. It normally is like a butterfly. But you're not like multiplying or anything. It's a simplifying thing. It's a dividing. Okay, so we're going to try the next problem. 3/5 of 10. So the first thing I'm going to do is I'm going to do my smush math. 3 times 10, all that means is I'm just putting them together in the top and the bottom. 5 times 1. So if you like standard algorithm, do that. If you already totally get standard algorithm 2.0, go ahead and try it. If you like it and you get it, do it. If you don't, fine. Awesome. So either way, just make sure you get the answer. We're going to check. So I'm going to do standard algorithm first. 3 times 10, 30. 5 times 1, 5. Okay, so the awesome thing is when I said 5 times 1 and I hear 6, that's not what I was asking. It makes me think that you don't know 5 times 1. So make sure that you answer what I'm asking. So 30 divided by 5 is 6. So your final answer should have been 6 with either one that you were doing. So if you did standard algorithm 2.0, you should have got 6 also if you did it correctly. So if you did it the second way, 3 times 10 over 5 times 1, you should have noticed that 5 can go into 10. So 5 can go into 5 once. 5 can go into 10 twice. So 3 times 2 is 6. 1 times 1 is 1, and you end up with 6. It doesn't matter which way you do it, as long as you do it right. If you ended up doing bar model, doesn't matter. 3/5 of 10. You've got 3 of them. If you do 10, 3, 4, 5, 10 divided by 5, each unit is 2. You have 3 of them, 2 times 3, 6. You still get the same answer. It's the same thing. But see, I don't want to do repeated addition because I don't want to write out 3/5 10 times. That's a lot of work. But I can do either one of those. Bar model works if you do it correctly. Okay? So I want you to try. Now I want you to look and see. This is 7/6. What do you notice about 7/6? It's improper. So if I'm starting off with an improper fraction, what do you know about improper fractions? Are they less than or greater than 1? They're greater than. So will my answer be less than or greater than 24?
Greater.
They'll be greater. So your answer will actually be bigger than 24. Because if I did, remember how before when we were doing our fraction parts, guys, quit writing real quick. When we did like 1/4 of 8, and we ended up with 2. And we did 2/4 of 8, we got 4. And we did 3/4 of 8, we got 6. And we did 4/4 of 8, we got 8. If you go greater than 1, if I do 1, I get that same number. If I did 6/6 of 24, I'm going to get 24. Well, now that I'm going bigger than 1. So my answer is going to be larger than what I'm starting with. So don't freak out when your answer is larger than 24. Because if you're actually paying attention, those of you who actually pay attention to your answers, don't flip out if your answer is larger than 24. Because this number is bigger than 1. So go ahead and just try this first one. 7/6 of 24, however you're going to do it, and see what you get. All right. So 7 times 24 over 6 times 1. So this one might be where I actually really want to figure out if I'm not comfortable doing 2.0. I might really want to do it because, man, 7 times 24, that's a big number. 8, 2, 14, 16, 168. Now, am I saying that that's wrong? No, it's just big. Over 6. Now I have to divide that. 6, 168. 6 can't go into 1, but 6 can go into 16. How many times? 2. That's 12. 4. Bring down the 8. 6 into 48. 8. So this, you end up with 28. You end up with 28.
Yes.
Good. So you see how it went from 24 to 28 because this was more than 1. Your number got larger. So if you were doing Smush Math 2.0, then 7 times 24 over 6 times 1, hopefully you notice that 6 can go into 24. How many times can 6 go into 24?
4.
4 times. So 6 goes into 6 once. 6 goes into 24 4. So now you just have 7 times 4. 28 over 1, so you just get 28. So it made it easier if you were able to do it this way. It's not wrong to do it this way, it's just easier. Doesn't matter. Okay? Now, are you going to be able to do this with this problem?
Yes. Yes.
Think about your basic facts. If you have 7 times 27 over 6 times 1, are you going to be able to do? 6 does not go into 27. Now, one thing, okay, before you start writing anything, one thing I want you to think about before you start writing. Good, pencils down. Is there a number? Think about simplifying because it's not always going to be that exact number. Whenever we were simplifying, if I had, say, I'm trying to think about just some random number, 9 over 21. Now, 9 can't go into 21. But did they share a number that could go into both 9, and 21? 3. So, is there a number that can go into both 6 and 27? 3 and 9. 9 cannot go into that.
3.
So, you may not be able to make it super small, but you can make it smaller. So, sometimes it's not going to be like we have a 1 on the bottom, but you can make it smaller. So, you can do it standard if you're really not comfortable, or you can attempt 2.0. So, go ahead and try that. And okay. 7 times 27. 49. 14. 8. 189. Yeah. Over 6. 6 into 18. 3. 6 into 9. 1. So 31 and 3, 6. Which can actually be that ends up on a EQT or multiple choice test. You won't see 3, 6. Okay, or 7 times 27 over 6 times 1. 3 can go into 6 2 times. 3 can go into 27 9 times. 7 times 9, 63. 2 times 1 is 2. 2 into 63. 2 goes into 6 3 times. 2 into 3 once. Oh, look. Ooh, it already simplified it for me. 31 and 1/2. Oh, look at there. Mia, your look of disgust is funny. You're like, oh, I hate you. You're just like, pretty funny. See, when you go to lowest terms, it's already simplified. So, understand, measurement conversions are the same thing. Don't make them hard just because you're going from one unit of measurement to another. Okay? This ends up being one of the harder things because y'all don't know your conversions. Okay? So I'm going from 2/3 of an hour and I'm changing it to how many minutes is that? 2/3 of an hour, and I want to know how many minutes is that. So the first thing I'm doing, now again, y'all know that I make a million steps out of everything because I want you to understand where is everything going. Because sometimes when you're doing conversions, you multiply. Sometimes when you're doing conversions, you divide. So one thing I want you to remember, one of my students actually taught me this. If I'm going from a big unit, hour, to a small unit, minutes. Aren't hours bigger than minutes?
Yeah.
Big to small, you multiply. If I'm going from small, if I were going from minutes to hours, small to big, you divide. So I made a division symbol with my face. Small to big, I made a line, dot, dot with my head, divide. So big to small, multiply. Small to big, divide. Okay? So I'm going from big to small, big to small, multiply. So I'm going from an hour to minutes. So I need to know an hour. How many minutes are in 1 hour? 60. So I'm going to change from 1 hour to 60 minutes. That's all I have to do. So it's 2/3 times 60. That's all. If my stuff was over here on this side, if I had my fraction over here and I was changing it to whatever over here, that's when I divide. If I have a number over here and my other number's on the other side of the equal sign, that's when I divide. If they're on either side of the equal sign, you divide. They're both on the same side, I multiply. 2/3 of 60. See if you can solve that by either method, standard or standard 2.0. So 2 times 60 over 3 times 1. 2 times 60. I know that 2 times 6 is 12. So 2 times 60 is 120. 3 times 1 is 3. 3 into 120. 3 cannot go into 1, but 3 can go into 12.
4 times.
4. Cannot ignore that 0. How many times can 3 go into 0?
0.
0. You can't.
4.
So your answer is 40 minutes. Every number in the house gets a number on the roof. Not worried about that front one anymore. I really only worry about that when we're doing decimals. 2 times 60 over 3 times 1. 3 can go into 3 and 3 can go into 60. I know 3 can go into 60 because 3 can go into 6. If 3 can go into 6, it can go into 60. So 3 can go into 3 once. How many times does it take for 3 to get to 6? 2. So how many times is it to get to 60? 20. 2 times 20, 40. Still 40. Same thing. 3/4 of a foot. What do you know about a foot and inches?
Foot is 12 inches.
One. I am multiplying because I'm going from big to small. So I multiply. 1 foot is 12 inches. So I'm taking my foot and I'm making it 12 inches. Oops. Got it down. Inches. Inches. 3/4 times 12. 3 times 12 over 4 times 1. 36 over 4 inches. 3 times 12 over 4 times 1. 4 can go into 4 and 4 can go into 12. 4 divided by 4 is 1. 12 divided by 4 is 3. 3 times 3 is 9. 1 times 1 is 1. Oh, okay. What? What are you motioning? What? Oh, okay.